Hello friends, in this video we are going to learn about divergence of a vector. I am going to tell you the procedure and method to find divergence of a vector. First of all, to find out the divergence of vector, you must know nebula. This is nothing but called as a differential operator. And you must have vector point function. That means we can find out divergence of vector point function. Let us say vector f. Let vector f is given by f1i plus f2j plus f3k. So divergence is defined as a nebula dot vector f. So this is called divergence of f. Vector f. So divergence of f, that is nebula dot vector f, equals to here the value of differential operator, that is I dou upon dou x plus vector j dou upon dou y plus vector k dou upon dou z dot vector f, that is f1i plus f2j plus f3k. This is equivalent to the dot product of nebula and f. So this is equivalent to dou f1 upon dou x plus dou f2 upon dou y plus dou f3 upon dou z. Some people call it as a dou and some people call it as a daba. I do call as a dou. So dou f1 upon dou x plus dou f2 upon dou y dou f3 upon dou z. This is equivalent to nebula dot f, that is the divergence of f. For example, if vector u equals to xyzi plus 2x square z plus y square xj and xz square k, find nebula dot u, that is nothing but divergence of u at 1, 2, 3. So here we are given vector u equals to xyzi plus 2x square z plus y square xj and xz square k. Comparing it with u1i plus u2j, there are vectors of course I, j and the u3k, where u1 equals to xyz and u2 equals to 2x square z plus y square x and u3 equals to xz square. Now divergence of u is given by nebula dot vector u, which is equals to dou u upon dou x plus dou u2 upon dou y plus dou u3 upon dou z. I repeat once again, divergence of u equals to dou u1 upon dou x plus dou u2 upon dou y plus dou u3 upon dou z. So putting the values of u1, u2 and u3, and now we'll do derivative, partial derivative. So dou upon of xyz with respect to x. So here y and z are constant and derivative of x is 1. And in the second case we have to do with respect to y. So this is 2x square z is a constant, derivative of 2x square z equals to 0, and y square derivative 2y and x as it is. Now in the third bracket we are doing with respect to z. So x as it is and derivative of z square is 2z. Therefore divergence of u is equals to yz plus 2 yx plus 2 x z. Since we have to find out divergence at point 1, 2, 3. Therefore, divergence of u at point 1, 2, 3. In place of x, we write down 1. In place of y, y equals to 2 and z equals to 3. So this equals to y into z, 2 into 3 plus 2 y into x, 2 into 1 plus 2 into x into z, that is 2 into 1 into 3. Therefore, divergence of u at point 1, 2, 3 equals to 6 plus 4 plus 6 equals to 16. So finally, we got the result. The divergence of u at point 1, 2, 3 equals to 16. Example 2. Here, vector u is given to us and phi is given. We have to find out divergence of phi into vector u at a given point 1, 0, 2. Solution. First of all, we'll write the formula for nebula dot phi of vector u equals to nebula phi dot vector u plus phi nebula dot u. Now, to solve this question, we need to find 4 things. One is the gradient of phi. Second one, phi value at 102. Then divergence value at 102 and vector u value at 102 at the point 1, 0, 2. So we need to find these 4 things. So first we'll find gradient phi equals to, so gradient phi equals to I into y plus 0, 0 because derivative of y square z is 0, derivative of z square is 0. Similarly, dou phi by dou y, dou phi by dou z. So we get gradient phi equals to I y plus j x plus 2yz and k into y square plus 2z. So gradient phi equals to I into 0, putting the value of x, y, z here. X equals to 1, y equals to 0 and z equals to 2. Now j 1 plus 2 into 0 into 2 plus k 0 square plus 2 into 2. Therefore, gradient phi at 1, 0, 2 equals to 0i plus j plus 4k, and phi value at 1, 0, 2 equals to 1 into 0 plus 0 square into 2 plus 2 square equals to 4. Now we'll find out divergence of u. It is given by dou u1 upon dou x, dou u2 upon dou y, dou u3 upon dou z, where u1 equals to x square, u2 equals to y square plus z square, and u3 equals to x square plus y square plus z square. And divergence of u nothing but dou u1 upon dou x plus dou u2 upon dou y plus dou u3 upon dou z. Therefore, divergence of u equals to 2x plus 2y plus 2z. Now divergence of u at point 1, 0, 2 equals to 2 plus 0 plus 4 equals to 6. Now vector u value at point 1, 0, 2 equals to I plus 4j plus 1 plus 4k, that is equals to I plus 4j plus 5k. So vector u equals to I plus 4j plus 5k. Let us revise. First I obtained a gradient phi at 102, then I obtained the phi value at 102, then divergence of u and vector u. So I obtained the four things. Now I am going to put all these values in the formula. Which formula? This formula, that is divergence of phi vector u equals to gradient phi dot u plus phi multiplied by divergence of u. So going to put these values, we get the final result. Divergence phi, that is 0i plus j plus 4k. Now putting all respective values here, and vector u, that is dot vector u I plus 4j plus 5k plus phi value nothing but 4, and divergence of u value, that is equals to 6. So this is equivalent to 0 plus 4 plus 20 plus 24. Therefore, divergence of phi u vector equals to 24 plus 24 equals to 48. This is required solution. So thank you for watching this video. How did you find? I hope you are benefited by this video. Now you can easily find out the value of divergence. To watch the similar type of video, please like, share and subscribe the channel. Meet you again with another topic, another video. Till then, wish you good luck, all the best.